This video will discuss how to find the surface area and volume of spheres. First, what is a sphere? You can think of a sphere as a three-dimensional circle, so a lot of the terms that you see for circles you will see for spheres. The definition is the set of all points in space equidistant from a given point. Circles are the set of points equidistant from another point in a plane. Now we're in space, so not only is this circle, say, equidistant from this center point C, you can also have another set of points, and there's maybe another circle that will be equidistant. And each one of those circles that you can create within the sphere, all of them have the same center, and all of them will have congruent radii. The center, again, is that point from which we will be equidistant, and the radius is the distance from the center to any point on the sphere. A chord, like a chord on a circle, is just when you connect any 2 points on the sphere together. And so here's an example of a chord. And the diameter is just a special chord that includes that center point right there. So if you have seen my other videos on surface area of polygons and other solids like cones and cylinders, some of them were kind of tricky to figure out. I'm happy to say the surface area of spheres is much simpler. Here's our formula, 4 pi r squared. And so you're just basically plugging in. If I want to find the surface area of this sphere, I write down my formula. And I identify the things I need. In this case, all I need to find is the radius, which they gave us. It's 9. So now I can plug in. So it's 4 times pi. R squared, 9 squared is 81. So to get my exact surface area, I just multiply the constants there, the 4 times the 81. And I get 324 pi square inches. That would be the exact surface area. But if you go ahead and multiply the pi, you will get an approximation. And I will round to the nearest tenth here. I got 1,017.9 square inches. And that is the surface area of that sphere. This is a case where I know the surface area and I want to find diameter. I'm going to underline that because obviously we have to be a little bit careful. Diameter is the same as twice the radius. I'm just going to have to find the radius and then multiply by 2 to get the diameter. You start with that formula. Surface area is 4 pi r squared, and we're going to solve this for r. First thing I'm going to do is divide by 4 pi on both sides. And I do that because that will cancel out those values. So r squared will just be the surface area over 4 pi. To get r, I'm going to take the square root of both sides. And I'm only really interested in that positive root because I don't want a negative radius. Doesn't make sense here. It's the square root of the surface area divided by 4 pi. That's radius, but I actually want diameter. So if diameter is 2 radii, that means I'm going to take 2 times that root that I figured out before. Now I can substitute in values. So it's 2 times the square root of 12.25 pi. That's actually a pi there. A little hard to tell, but that's what it is. And I'm glad it's a pi because that makes this cancel out, which makes things a little bit easier. No pi's to worry about. And that comes out to be, if you put it in the calculator, approximately 3.5, maybe even exactly. And these will be centimeters. That's my diameter. Volume is also, I think, a little bit easier than some of the other volumes we've looked at. Not doing any derivations of where these are coming from, but the volume of a sphere is 4/3 times pi times r to the 3rd power. So here's a bowling ball. I know its diameter. It's 8 inches. Find its volume. I'm going to say don't worry about the holes drilled in. I want the entire volume, including the whole space in there. So just that sphere itself. If diameter is 8. That tells us the radius will be half that, or 4 inches. Volume equals 4/3 pi r cubed, which is 4/3 pi times r to the 3rd power. Now, you may or may not be good with cubing numbers. Perhaps you haven't done it all that much. You can use the calculator, and I'm going to use the Desmos graphing calculator. This is the Virginia testing version, but it works pretty much the same as the other ones. So I'm trying to figure out what the volume of that bowling ball was. 4/3, 4 divided by 3, and then pi r cubed. Pi, my r was 4, so I'll put that in. And then how do we raise things to the third power? One way is to use the little caret symbol. It's above the 6. You do a shift and a 6, and it moves you up into that superscript position, and you can just type in the 3. Another way would be to use the little keyboard that comes with it. So if you see this thing where it says A to the B, you can type that in as well to get there. But now that I have it, I can see what the answer or the result is. 268, if I'm rounding to the nearest tenth, that would be 268.1. So that's approximately 268.1. The units here are inches, so these are cubic inches because volumes, cubic units, how many cubes fit in there. Find the radius of a sphere when I know the volume. I want to find the radius of a sphere when I know what a volume is. Let's start with the actual formula. V equals 4/3 pi r cubed. And then I'm going to solve this for r because that's what I want, the radius. So you're just going to use algebra. First thing I would recommend doing is multiplying both sides by 3 because that will cancel out that 3. And then I'm going to divide by 4 pi on both sides because that will knock out the 4 and that will knock out the pi. And I'm left with r cubed equals 3 times the volume over 4 pi. Nearly there. I don't really want r cubed. I want r. So you take the cube root of both sides. So r will be, this time the cube root, putting the little 3 there, 3v over 4 pi. This formula will work anytime you know a volume and you want to find the radius. So I just plug in. So my r will be the cube root, don't forget that little 3, of 3 times this number that they gave us, 1436.76, whole thing over 4 pi. And I'm just going to put that in the calculator. So you may or may not know how to find the cube root. You can raise the whole thing to the 1/3 power. You may not know how to do that yet if you haven't had Algebra 2 or beyond. So you can just bring up this little keyboard in this Desmos calculator, and you're going to click on the word functions. And then you're going to go under miscellaneous. That's MISC there. And right sort of in the middle-ish, we've got something that has an n with a square root. So you're going to press that. And if you see where the cursor is, it's blinking. It's saying, which root do you want? So I'm going to put my 3 in right there. Now it knows it's a cube root. So very important if you're finding radius with volume of spheres. And now I can type in the numbers. 3 times that volume that they gave us. And then I'm going to divide that by 4 pi. And then I get my result, and it's about 7. So this is approximately 7 meters. That would be the radius of a sphere with that particular volume. And that's kind of all there is to it. Go ahead and pause the video. I'd like you to try these U-tries. This is a pi, by the way, so that's really 36 pi square meters. Yes, I mean you. Pause it, and then come back and we'll go through these. And we are back, and if you haven't tried them, try them. But let's go through these. The diameter of a sphere is 50 feet. Find the surface area. So I'm going to want the surface area formula, which for a sphere is just 4 pi r squared. Now they're giving us diameter. This is where you have to read carefully. So if diameter is 50 feet, the radius will be half that, or 25 feet. And then we just plug in. It's 4 times pi times 25 squared. If you put that in your calculator, this will come out to be 2,500 pi. That would be the exact surface area. So 2,500 pi square feet. If you multiply that out, and I'm going to round to the nearest tenth, that comes out to be approximately 7,854.0 square feet. Okay, the surface area of a sphere is 36 pi square meters. Find the radius. So we did this a little early, but we can do it again. So the surface area is 4 pi r squared. You're going to solve that for r by dividing both sides by 4 pi and then taking the square root. So r will be the square root of whatever the surface area is divided by 4 pi. And we can substitute in. It's the square root of 36 pi over the 4 pi. Because there's pi in the top and pi in the bottom, they cancel out. We are going to get a nice rational number here because 36 over 4 is just 9, and the square root of 9 is just 3. So 3 meters would be the radius in this situation. Next one, the radius of a sphere is 7 yards. Find the volume of the sphere. So the volume formula is 4/3 times pi r cubed, so r to the third power. Radius is 7, so we can just plug all that in. 4/3 pi, and then 7 to the third power. Put all that in your calculator. Let's put this one in the calculator. So I've got 4/3 times pi, and then it's times 7 to the third power. So this would be an approximation. Now, if they wanted the exact answer, you would take the pi out with the understanding that I'm going to add pi to whatever I get as my result. Now, I want to turn this into a fraction. I can see it's some number over 3. And again, this is a really nice feature of the Desmos calculator. It will, if it is a rational number, if it is a number I can turn into a fraction, it gives me this little box over box that if I press it, it will turn it into a fraction. If you needed this to be exact, it would be 1372 pi over 3. If you want the approximation, you can multiply it by pi again. So this one, if you want the exact answer, it is 1372 pi over 3. That's exact, or to the nearest tenth, approximately 1436.8 cubic yards. And then finally, find the radius of a sphere when I know the volume. So volume is 4/3 pi r cubed. We're going to solve this by r by multiplying both sides by 3 over 4 pi and then taking the cube root. So review this in the previous part of the video if you're still unsure where that came from. So that's 3v over 4 pi, and this is a cube root. So I can substitute in. So this is the cube root of 3 times 91.95 over 4 pi. And we just put this in the calculator. So again, cube root, go to functions under miscellaneous, and then find the thing with the little n and a root. And this is a cube root, so you put in a 3 there. And then we can type in what we want, which is 3 times 91.95. And that's divided by 4 pi. And to the nearest tenth, that's approximately 2.8. And these are meters. Surface area and volume of spheres, not too tough. Hope this was helpful. As always, thank you for watching.